Hey everyone, imagine waking up tomorrow to a news alert. Major earthquake expected in your city within the next 72 hours. Would you evacuate? Stock up? Or just roll your eyes because we've heard false alarms before? For over 100 years, scientists have been trying to give us that kind of warning, and for 100 years they've mostly failed. But right now, something is changing. Fiber-optic cables, satellites, cosmic rays, and artificial intelligence are coming together in ways that sound like science fiction. Some researchers are calling it an earthquake shield, a global early warning system that could finally see a big quake coming days or even weeks ahead. So is this real? Or just another overhyped dream? Stick with me because by the end you'll know exactly how close we actually are. Let's dive in. Every year the Earth shakes about 1 million times. Most quakes are tiny, but every few years one monster hits. Tohoku 2011, Turkey Syria 2023, Morocco 2023, and in minutes hundreds of billions of dollars and tens of thousands of lives are gone. Here's the brutal truth. We are incredible at knowing where big earthquakes are likely. The Ring of Fire, the San Andreas, Istanbul, Tehran. We've mapped them all. We are also great at giving people 10 to 60 seconds of warning once a quake has already started. Japan and Mexico do this brilliantly. But telling you a magnitude 8 is coming next Tuesday at 3 p.m.? That has never happened. Not once. Ever. Why? Because faults are chaos machines. They're made of jagged rock, filled with water, heated and squeezed at insane pressures. A tiny change, literally the width of a hair, can decide whether a fault stays locked for another century or lets go tomorrow. That's called nonlinear chaos, and it's the same reason weather forecasts fall apart after about 10 days. So most seismologists have said for decades, reliable short-term prediction is impossible. But a growing group of scientists is starting to whisper, maybe not anymore. Let me introduce you to the 4 pillars of what people are calling the earthquake shield. There are already over 5 billion kilometers of fiber-optic cables buried around the world. That's enough to wrap around the Earth 125,000 times. Using a technology called distributed acoustic sensing, we can shoot laser pulses down those cables and turn every meter into a mini seismometer. One cable in California recently recorded over 800 earthquakes in a single month that normal stations completely missed. Suddenly, we can watch microtremors and slow creeping movements along faults with insane detail. Satellites like Europe's Sentinel, one take radar pictures of the entire planet every 6 to 12 days. They can see the ground rise or fall of the ground to the thickness of a coin. Before the 2019 Ridgecrest earthquakes in California, scientists saw the ground inflate like a balloon for months. Combine that with continuous GPS stations, and we now have a global strain meter. Cosmic rays from space constantly rain down on us. Particles called muons can punch through kilometers of rock. By putting detectors around or under mountains, we can make 3D density scans, almost like an X-ray of the planet. It's already been used on volcanoes. Now researchers want to point it at faults. Add super-sensitive quantum gravimeters that detect tiny changes in gravity when rock squeezes or fluids move, and we're starting to see stress building deep underground. Here's where it gets wild. We're drowning in data, terabytes every day from cables, satellites, gravimeters, you name it. No human can spot the pattern, but AI can. In lab experiments and a few real cases, machine learning models spotted subtle changes in microseismicity, deformation rates, and even electromagnetic noise weeks before the May shock. The key is multimodal fusion, teaching the AI to watch dozens of signals at once and say, this combination only happened right before big quakes in the past. So we have the sensors. We have the eyes in the sky. We have the deep scanners. And we have AI that never sleeps. Is that enough to predict earthquakes? Let's be honest, there are massive roadblocks to predicting earthquakes. First, chaos is real. Even if we watch every millimeter of a fault, the final trigger might be a microscopic crack or a pocket of pressurized water 15 kilometers down. We may never see that trigger, no matter how good our toys get. Second, data gaps. 70% of big earthquakes happen under the ocean. Guess how many seismometers we have on the ocean floor? Almost none. Covering the oceans with fiber or buoys will cost hundreds of billions. Third, false alarms destroy trust. If we cry wolf too many times, the next time a real danger comes, nobody evacuates. Remember the 1980s when Italy convicted scientists for not predicting an earthquake? The opposite can happen too. Imagine evacuating Los Angeles for a week and nothing happens. Fourth, politics. Earthquakes don't care about borders. Turkey, Syria 2023 showed how hard it is to share data across hostile frontiers. A true global earthquake shield needs China, the US, Russia, Iran, everyone, sharing real-time data. Good luck with that. So deterministic prediction, Tuesday at 3:15 p.m. is probably impossible forever. Bet, and this is the big bet, probabilistic, short-term forecasting with useful lead time, that might actually be within reach. Picture the scenario in 2035. An AI system notices a weird combo, slow slip creeping up the Cascadia subduction zone, unusual microquake swarms 20 kilometers deep, slight inflation on satellite radar, tiny gravity changes detected by quantum sensors, and a subtle shift in the electromagnetic field. The system raises the probability of a magnitude 8+ in the Pacific Northwest from 0.002% per day to 15% within the next 10 days. That's not a guarantee, but it's enough for hospitals to move patients to ground floors, gas companies to shut valves, ports to secure cranes, and schools to cancel classes or move kids to open fields. Even if the quake never comes, the cost is tiny compared to one Tohoku scale disaster. And if it does come, you just saved tens of thousands of lives. That is the realistic version of the earthquake shield. Not perfect prediction, but turning, when, not if, into probably this month, be ready. Right now, Japan and Iceland have prototyped distributed acoustic sensing networks. California is wiring up hundreds of kilometers of fiber, and Europe's testing muon detectors on faults in Italy and Japan. AI labs have retrospective studies that predicted several recent quakes with days to weeks warning, but only after the fact. Real time is harder. The consensus among the most optimistic experts? We might see regional prototypes giving useful warnings in well-watched areas like Japan, California, Turkey, and New Zealand by the early 2030s. A truly global system that covers subduction zones and poor countries? Probably 2040s or 2050s. So here's the bottom line. We will almost certainly never be able to predict every earthquake with pinpoint accuracy. The Earth is too chaotic, and some faults will always surprise us. But we are closer than ever to turning blind panic into managed risk. An earthquake shield won't stop the ground from shaking, but it could give millions of people hours, days, or even weeks to get ready. That's worth fighting for. If you want to see this future happen faster, here's what you can do. Support open scientific data sharing. Tell your politicians. Push for fiber companies and governments to allow DS on existing cables. Follow the research. I'll link the best papers and projects down below. And if this video made you think, hit that like button, drop a comment. Do you think we'll ever predict big earthquakes in your lifetime? And subscribe, because I'm going to keep tracking this story as it unfolds. Thanks for watching. Stay curious, stay safe, and I'll see you in the next one.